So given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use built-in function operator. Real time 231 2 power 31 constraint. So basically we have to return square root, and the best way to return it yeah, it's use sorted property of integers. But how about we do binary search on that? If we say, let's say we have two numbers, n1 and n2, and let's binary search. Let's implement binary search. We do n2 minus plus n1 multiplied by 2, and then we have to have a condition function. So idea is, let's write it in English first. Idea is use binary search function. So we have let's say function try sqrt, right? And we pass some value, and this value, this function could return if we need a smaller, or if we need bigger number. Then we use binary search, and we start with some numbers like from 1 to x. I don't know how we're gonna find x. We are going to find x, and as a result, we're gonna binary search function, this try sqrt. So instead of comparing numbers, we will compare, we will call this function with our number with a mean, right? And then if it will return that we have to go smaller, we go smaller. If we have to return bigger, we go bigger. And this is kind of like optimizing binary search function parameter. Yeah, and so this will be like optimization parameters. So we call a function, and with middle point, right? If function return if function return, we're gonna go bigger, true, smaller, false, right? If function returns that we have to go bigger, we call, but it has to return. Okay, let's say smaller minus 1, bigger 1, and exact equals 0, right? So if function return, we have to go bigger. Oh, if 0, right? We return a leaf or we can call function right here. So we can say result equal function with middle point, and if result is 0, or if result is less than 0. Oh, we don't have to do a if, right? We can just have r more than 0. What we're gonna do, it's bigger. So we have to go small. Oh, let's call this too big, too small. We can actually use this as a function, right? And define it here. Let's do this crazy thing. So if result equal too small, then we have to go bigger, and we call binary search with middle point and um, high range. Else we call binary search with probably +1, right? With um, 1 and m minus 1. Minus 1? No, not minus 1. Okay, let's take 5 minutes break. Okay, let's get back to our task. And so yeah, and basically we just return whatever we have with a function, but we also need try security implementation, and what we're gonna do, we're gonna multiply, right? So we have our target x. So what we're gonna do, if value multiplied by value. So uh, let's have our try. If our try more than x, we say too big. We return too big. Else, if our value somehow we have to figure out why, like so meaning, what if our value never be exact, right? We have 8 and 2. So what we're gonna do, if it's 4, oh, it's still less, right? We cannot do that. We have to figure out how to do between two values, maybe. So no, it's not binary search. Um, we kind of can use binary search, but we have to figure out. So if t equal x, it's not equal. And someone between 2 and x divided by 2. So what if we say if we int like this, right? Oh, f1 is here. And it's not defined middle point. Oh, middle point called R. Oh, middle point is MD. Okay, let's call it M. Yep, I mean, but the thing is, maximum recursion gap. Yeah, I would print what we are trying, just for fun. Yeah, that thing is not working, right? It's like we have to figure out between two of them, between two numbers, and select smaller one. Like if this number, if 2 is too big, too small. Yeah, so it's interesting how it's settled down between 3.9 for some reason, for 8. Okay, how about another solution? How about we, yeah, so it's 323. What if I call it for m and m plus 1? And we call it result 1, result 2. And if I say if result 1 is too small and result 2 is too big, I will return R1. Right? So it's 2, 3. Okay. But it could be also exact, right? If you like 9 and 3. But here we have to find number between of them. So we have middle, we have result 1, we have result 2, and we have oh, it's returning exact. Okay, so I can say if R1 equal exact, I will return R1. If R2 equal exact, I will return R2. No, I don't have to return like R result. I will return M1 and M plus 1 M. So this one. 3 is too big. 3 and 4 too big, too big. 2. 2 is too small, too big. Yes, 2 is too small, 1 is too big. If R1 too small and R2 too big, we return M. Why m is not? Oh, I don't have to return negative. Or yes, I do have to return negative. Oh, because recursive call. It's like binary search recursive. I shouldn't do recursive. Oops. Maximum recursion. So if x is 0, what should we return? Oh, I have to printing. Yeah, 23. Nobody else knows. Okay. Is it a function call? Yeah. Uh, yeah, really cool. Exactly, you used exactly what, but it's okay. So yeah, I like it because it's good exercise on binary search. So if yeah, let's go to the next one. We are playing guess games. Game I'll pick one. And guess which peak. Every time pick, pick. Copy the final IPA. Guess. Guess. Okay, it turns three possible results. Okay, this is exactly what I implemented. Wow, it turns a number. Okay, so what we're gonna do? We're gonna use the sum function. Right. And then what we're gonna do, we're gonna minus one is higher. Okay, so it's slightly different. So exact is oh yeah, too big is minus one, too small is one, and exact is zero. And here we call, instead of f1, we call our function guess. Right, we have just have one result. and if we return middle point. If too small or too big, we don't need this, right? And what we do, we just return from 1 to n, right? Exact. Oh yeah, sorry. Here. Yeah, this is classic. Given an array num sorted non-decreasing order, return the maximum between the number of positive integer and negative integer. So either 0 is either there are 3 positive integers and 3 negative integers. So we are searching for 0. Whatever is 0, then yeah, so our approach will be binary search for 0, then for example like this, right? We have we have 0, 1, 2, 3, 4, 5. Yeah, so result, if we found where 0 should be, and it should be after 2, so result will be length of nums minus index of last element. Last element before 0. So yeah, basically we have to find last element before 0. We will use the same thing we developed here, except we will be searching we will get nums yep, we start from so we have length of array, which is length of nums. Yeah, let's take a break. Okay, so our function have to find basically 0 and return it. And we assign it to z0, and then we return length minus index of 0. And we are searching between 0 and L. What will be our call? Our call will be we get a value from nums 3, and our x will be 0, right? That's it. Maximum recursion. Okay, so we are going off recursion. So if this is exact, so we start from 0 to L. Right. Oh, it's a really high numbers. We don't have 0 here. Now I see the problem. We have 0, 1, 1, 0, 1, 1. So I can say if, even before calling it, if nums 0 more than 0, we just return L. But still problem persists. For example, oh, we may have a higher, right? Minus 1. Six minus one minus one. 6 minus 1 minus 1. We found 6, okay. So 0, 1, 2, 3, 4, 5, 6. Perfect. So what we're gonna do, we're gonna 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 minus 6. Huh, okay. Yeah, so my calculation are not correct here. Expected 7. Return the maximum of position and maximum position. Maximum of position and negative position. So positive position will be number of positive integer is false. So number of positive integers not pos and number of negative. So number of positive will be z plus 1. Number of negative will be z. No, number of positive will be always max. No, not correct. Number of positive will be L minus Z minus 1. Number of negative will be Z. So we have to return max of positive versus negative. One, two, three, four, five, six, 7. Oh, okay. So it's based from 0, so z plus 1. Oh, I forgot again. Oh, it's not working. Okay. It's not working because number of negative 3. Yes. 0, 1, 2, 3. Oh, it's found 0. Exact match. Okay, I have to exclude 0 then, right? Number of negative will be 3. Okay, it's more complex than I thought, so we have to find. So what if we have so our code will not work in this case, right? Because we found 0 and we can tell number of negatives, right? Number of negative is 4, which is only if if nums z equals 0, but it's not gonna work anyway. Because it's gonna be test case which will return me wrong answer. Yep, all zeros, 500, 0, 0. No, I think we have to change. We have to change function. If we have to find a smaller negative and smaller positive. How about we will search for -1 and 1? So -1 will tell us position of negative. All right. Let's add x here. Yeah, I like this idea. So it will be, we will search for insertion point for -1, search for insertion point for +1, and then positive index will be, so last negative number position will be this will be negative. This will be L minus whatever we have. Let's call it Z, and positive will be L minus Z. So we have to search binary search for -1 and +1. Yeah, let's go and set here. Accepted X. And then we call this X here, pass XX parameter. Then we binary search for which would be neg binary search for -1. Then we z search binary search for actually we don't need to start from 0, right? We can start from negative. Yeah, we can start from negative and we can search for 1. Then our position will be the same. Positive will be the same, and we return whatever positive and negative. It's an argument. Oh yeah, be passing. Definitely passing x as a parameter here. Maximum recursion back. Oh, it's on zeros, right? Because it is original for -1. Okay, and we have 0, 0, 0, 0, 0, 0, 1, 1. Too big, too big, too big, too big. Okay, that's a problem. So our like this. Okay, so we can say here so if mass more than 0, right, we return all. Now if What if it's less than 0? Also, we can say if first 0 equals 0, right, we assign -1, else we assign one and 2, output 2. Why 3? Because it's 3. Zero, 1, 2. Okay. So first I found positive, negatives, and I found 0, I found positive. So negative will be 1, 0, 1. All right, I'm out of ideas. I think I have to think about this. It's kind of this is also, see, if what if I have 2 minus 1? This is my solution B will not gonna work too. So this is kind of tricky, easy, and I have to think more about it. Yeah, that's it for today. Thank you.